This section of videos will be about Section 5.6 in college algebra and context, annuities and loan repayments. An annuity is a financial plan where regular payments are made into a savings account, and we can use an exponential function to determine what the future value of the account will be. We will focus on ordinary annuities. An ordinary annuity is a financial plan where equal payments are made at the end of each period to an account that pays a fixed rate of interest compounded at the same time the payments are made. Just want to review some terms. Annuity and loan terms, they're really the same as in Section 5.5 with our compounding interest. S is the future value. A is the amount of the loan or the present value. R is the amount of the periodic payments. I is the interest rate per period. Remember, that's the annual interest rate divided by the number of periods per year. And N is the number of equal periodic payments. So N equals the number of payments per year times the number of years. The future value of an ordinary annuity. If R dollars are contributed at the end of each period for N periods into an annuity that pays an interest at a rate of I at the end of the period, the future value of the annuity is S equals the periodic payments times 1 plus I raised to the N minus 1 divided by I, and our answer comes out in dollars. Let's do a sample of that. To find the 5-year future value of an ordinary annuity with a contribution of $750 per quarter into an account that pays 10% per year compounded quarterly. Well, we're finding the future value, so S equals R times 1 plus I raised to the N minus 1 divided by I. And let's see what those values are. R is our $750 per quarter. So I equals the 10% divided by 4 quarters in a year comes out to be 0.025. And N equals the number of payments. So that's 4 times a year times the 5 years, or 20. So putting that into our formula, S will equal $750 times 1 plus 0.025 raised to the N, then minus 1, and that whole amount divided by I. When we put that into our calculator, we get out 19,158.49,324. Since this is money, we will round it to the nearest cent and get $19,158.49. So that will be our value after 5 years. We can also find the present value of an ordinary annuity. If a payment of R dollars is to be made at the end of each period of N periods from an account that earns interest at a rate of I per period, then the account is an ordinary annuity, and the present value is A equals R times 1 minus 1 plus I to the negative N divided by I. An example with this, a retiring couple wants to establish an annuity that will pay $1,800 at the end of each month for 15 years. If the annuity earns 6% compounded monthly, how much must the couple put into the account to establish an annuity? Well, we're using the equation, the current value equals the monthly payments, or the periodic payments, times 1 minus 1 plus I to the negative n all over I. And establishing those R will be our 1,800. I will be 0.06 percent. The end of each month, so 12 times a year. This comes out to 0.005. And N equals the number of total payments. So 12 times a year for 15 years equals 180. Plugging those numbers in, A will equal 1,800 times 1 minus 1 plus 0.005 raised to the negative 180 divided by I, which is 0.005. You put that in the calculator, the 180 times the numerator divided by the denominator will equal $213,306.3264. Since this is money, we'll round it to the nearest cent. It will be $213,306 and, rounding up, 33 cents. Thus, the couple will receive a payment of $1,800 at the end of each month for 15 years if they start with a lump sum of $213,306.33 in their annuity. Now you might note, if we take that monthly payment of $1,800 times 15 years times 12 times a year for monthly, they will receive a total of $324,000 in payments. So more than $110,000 more than they put in and started with. Next, we're going to talk about loans and amortization. Amortization is the process of repaying a loan by making all the payments of equal size. Now, all those payments include the interest and part of the remaining balance. So A is the debt in dollars, or the value you borrowed in the first place. R is the amount of the periodic payment. I is the interest rate per period. N is the number of equal periodic payments. I just thought I would remind you what those were.